What's up, guys? Today I'm going to be doing a short video comparing the two functions, logarithms and exponential functions. And so here's two which are actually inverses of each other, 2 to the x and log base 2 of x. Okay, of course the variables x and y would have to switch, but what we're going to see with their graphs, when you have the same base, you're going to notice that the inverses follow the same pattern as when we studied inverses in a previous unit. Okay, so the first thing I want to do is I want to fill out the table. Okay, and I'm here in Microsoft Paint, so I'm just going to kind of write them in. Bear with me. If I plug in, let's start with the 0. If I plug 0 into 2 to the x power, what do I get? I get a 1. Well, that's an ugly 1. Okay, 1. See if I can make my line a little bigger. All right, if I plug in a 1, what do I get? I get 2. And if I plug in a 2, what do I get? 2 squared is 4. Going this direction, 2 to the negative first is 1/2. And 2 to the negative second is 1/4. Okay? So with the logarithm, what you're actually going to do, notice that they didn't even put in the x row yet. Okay? Because remember that with inverses, the coordinates switch places. Okay? So what I want to do is for x, I want to go ahead and write in what we had for f of x on the other function because these are inverses. And of course that means the y, or the f of x, in this case the inverse f of x, is what we did have in the x row. So -2, -1, 0, 1, and 2. So because these are inverses, all you have to do is flip the x and the y. Okay, so now we want to graph. And what I'm going to do is I'm going to graph the original function in red, and we'll graph the new function in blue, the inverse, the logarithm function. Okay, so at -2, which is I guess somewhere out here, we need to graph 1/4, so it's pretty low, somewhere like around, let's see, we're counting in 2's, so that would be 1. 1/4 is going to be very small, it's like right about here. Let's get a bigger dot. Yeah, right about here. Okay, at -1, halfway here, we need to graph -1/2, which is about here. Okay, at 0, it's going to be 1. At 1, it's going to be 2. And at 2, it's going to be 4. In fact, let me go a little further. What would be 2 to the third power? That would be 8, right? I'm going to plot that one as well. And we could probably go one more. 2 to the fourth would be 16. Okay, so now all I need to do for the inverse is flip all of those points. And you don't even have to use the table if you don't want to. We can actually just look right here. Like, look at this point. At 0, the graph was at 1. So just like we did with our inverses before, if you've got a point at 0, 1, we're now going to put a point at 1, 0 for its inverse. It's a little off. It's right here. Okay. At 1, 2, there was a point, so we're going to put a point at 2, 1. Okay. The original graph had a point at 2, 4. So we're going to put a point at 4, 2. The original graph had a point at 3, 8, so we're going to put a point at 8, 3. And 4, 16, so we're going to go to 16, 4. Doing the same thing back in this direction should curve this way. So -1 was 1/2, so we're going to go out 1/2, and they'll go down to -1. And -2 was 1/4, so we're going to go out 1/4 and go down to -2. Now, if you remember your graphs for exponents, there's always an asymptote. In this case, the asymptote comes down and it is the x-axis. It's going to go like this. Okay, I don't know if I really want to draw that because my mouse is probably going to be kind of crooked, but you know the line's going to go like this and approach the asymptote. Well, this logarithm is going to go like this, and its asymptote is going to be, in this case, the y-axis. It's going to go down this way. Okay, we'll see if I can do this. I'm probably going to completely destroy my graph. Here we go. It's going to go like this. Something like that. It's going to go this way forever. And this is going to go down forever, approaching the y-axis but never getting there. Okay. Now, the original exponential graph is going to go like this. And it has an asymptote of the x-axis. Okay. It should never actually cross the x-axis. Okay, and that's what the graphs look like. Notice that, if I had drawn them correctly, they're both reflected across that dotted line y equals x that we learned about when we first studied inverses.